the present study is the effect of clove essential oil as a natural preservative in the oxidation of chicken hamburgers. Background: the use of technologies and compounds that prolong the useful life can guarantee a new destination for these meats. The processing of meat with the myopathies can contribute to minimized economy losses, since industrialized byproducts are responsible for the valuable increase in consumer acceptance. Objective: we evaluated the effects of including the clove essential oil as a possible substitute for the synthetic butylated hydroxytoluene (BHE) as additive in frozen chicken hamburgers. Methodology: analysis of antioxidant capacity, ABTS, and TPC and lipid oxidation were performed. The chicken breast meat was obtained a single batch from the commercial poultry processing unit in the western region of Paraná State, Brazil. After slaughtering, pectoralis major was removed from the carcass and cooled. After that, the breasts were packed in the plastic bags and transported to the poultry experimentation laboratory at the Federal University of Paraná from the Palotina sector, where they were frozen until the time of analysis. The treatments were defined as follows: addition of 0.01% clove essential oil (CEO), 0.01% BHE, and without the addition of antioxidant (STD). The breasts were watered under refrigeration 4 degrees Celsius ±1, grounded with the 6 mm mesh. Then were added 90% ground chicken meat, isolate soy protein, 8% salt, 1.5% monosodium glutamate, 0.1%, pounded garlic, 0.2%, pounded onion, 0.1%, and the pepper, 0.1%, were added for all treatments. Clove essential oil, 0.01%, was added for the CEO treatment, and the 0.01% BHE was added from the CON. The clove CO used obtained from the FERCMA, and the concentration used based on study carried out by Maria contributors and Montesquieu contributors. The BHE concentration used in this study followed the standards established by the Ministry of Health from Brazil for meat production, 100 mg per kilogram of product. To manufacture hamburgers, all ingredients were homogenized manually, and the hamburgers were molded as patties of 80 grams, 10 centimeters in diameter, and 2.0 in 8. The samples were individually packed in retractable polystyrene bags permeable to oxygen and taken to freezing in a freezer. For the analysis, the hamburgers from each treatment, 8 replicates in triplicate, were randomly removed on days 1 and 90 from the frozen storage. The phenolic content, the antioxidant activity, and the lipid oxidation of hamburgers were analyzed. To evaluate the antioxidant and phenolic capacity, meat extracts were obtained by extraction by ultra-2-hydroxy homogenization, centrifugation, and filtration on the quantitative paper. The phenolic content was determined according to the Singleton and Rossi with modifications, and a liquid of each extract was mixed with the following CO2 reagent and sodium carbonate, incubed in the dark by 30 minutes and had its absorbance measured at 725 nanometers. A standard curve of gallic acid was prepared. Results were expressed as milligrams of gallic acid equivalent per gram of hamburger. The percentage of radical reduction (ABTS) was obtained through the interaction of a BTS solution with potassium persulfate. The mixture was incubed in the dark diluted with ethanol to an absorbance of 0.70 and a liquid extract of the mixed with a BTS solutions and had its absorbance measured at 734 nanometer f 6 minutes. The radical elimination activity was expressed in a percentage reduction. 2 axes of the lipid oxidation samples of hamburger mixes and TCA solution, homogenized in the ultra-2-hexane centrifugation. The supernatant was filtered and mixed at 101 V per V with the T-bars reagent. The mixture was boiled, cooled, and the absorbance was measured at 532 nanometers. Concentration were determined using the standard MDA curve using 1,3,3-tetramethoxypropane. The results were expressed in an MDA per kilogram of hamburger. The significance has difference between the treatments was made by ANOVA and Tukey as post-hoc test. Results. Our results showed that the addition of clove essential oil had an oxidant effect on the frozen chicken hamburgers, reducing lipid oxidation process during the freezing. The essential oil showed the highest antioxidant activity and phenolic content at the end of storage. Addition of essential oils reduced the formation of secondary compounds from the oxidation process and consequently decrease flavor deterioration and can help maintain meat quality throughout its shelf life. This reduce indicate that clove essential oil can be used as a radical scavenge of inhibitor of the oxidation in meat because its compounds have antioxidant activity due to the ability to the donors of hydrogen atoms or electrons and capture free radicals, thus ending the reaction in the peroxide chain, decrease in the adverse effects of display time and the formation of the free radicals, prolonging the shelf life of the product. Conclusion. Therefore, clove essential oil has been promising natural antioxidant to increase the shelf life of meat productions, as well as a viable solution to replace the synthetic antioxidant BAT and other commercial additives widely used by the food industry.